Good morning everyone, welcome to the maths class. Today we are going to start a new chapter, that is Arithmetic Progression, and I am hoping that you all are practicing the chapters which you are already done with, because as we know that you need to practice a lot, that the only way to learn mathematics is to do mathematics. So I am hoping that you are doing practice and you are practicing a lot, and here also when we are going to start a new chapter, it is a fresh start, so just cooperate with that. Okay, so on this note, let us start our new chapter, the arithmetic progression or arithmetic sequence. Before we start and we actually learn what is arithmetic progression, let's see what is the term progression mean, or what is the term sequence means. Okay, meaning the progression or sequence is actually group of numbers which are arranged or in a way so that they are following a proper pattern, or you can say they advances in such a way that they follow a proper pattern in the sense, like if I write a sequence or group of number 3, 5, 7, 9, 11. So if you see, these are some group of numbers. They are advancing, they are increasing in such a way that we can find that there is actually a pattern. They are following a pattern. Like when you add 3, when you add 2 in 3, you will get 5. When you add 2 and 5, you will get 7. When you add 2 to 7, you will get 9. When you add 2 to 9, you will get 11. That means we can see that these group of numbers are following a particular pattern, and that's how these group of numbers can be called as progression or as a sequence. If I write a sequence or a group of number, let's say I'm writing 3, 9, 27, 81, 243. This time again I have written some group of numbers and they are also following a particular pattern. What pattern? Like when I multiply 3 with 3, that will give you 9. 9 into 3 again will give you 27. 27 into 3 will be 81, and 81 into 3 will give you 243. So this time the pattern is that each number is multiplied by 3, and that's how they are following the series or following the pattern. In the above series, in the above progression, if you see, we are actually adding 2 to each number to get the next number. So pattern could be anything. It is just that the group of numbers should follow a same pattern, and that's how they are increasing, or that's how we are writing the numbers, and that's how this group of numbers then called a sequence or progression. After that, let's see what is an arithmetic progression or arithmetic sequence. Okay, to see the arithmetic progression now or arithmetic sequence, if I take this series, now what is there in the series is that if you see, when you add 2 to each number, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and 9 plus 2 is 11. Every time actually you are adding a particular number. It could be 2, it could be 3, 4, 5, minus 1, minus 2. That means every time you are adding a particular number to one number to get the next number. Such kind of progression where you are adding something or to get the next number is known as the arithmetic progression. Okay, if I take another sequence like 13, 20, 27, 34. Okay, this is again a group of number and they are following a particular pattern. Every time we are adding 7 to each number to get the new number. Like 13 plus 7 will give you 20. 20 plus 7 will give you 27. 27 plus 7 will give you 34. So this time we are which number we are adding? That is 7, and 7 is being constant. Every time we will add 7 to get the next number. If I ask you what will be the next number, that is 34 plus 7. So that's how this is arithmetic progression. We have to, and if we want for a given group of number, if we want to check whether it is an arithmetic progression or not, we see that whether the numbers are following such patterns or not. Now we can see this thing in other way, as if I ask you like 13 plus 7 will give you 20 and 20 plus 7 will give you 27. We can also say this in this manner, like what is the difference between 20 and 13? That is 7. The difference of 27 and 20, that is 7. What is the difference of 34 and 27? That is again 7. So whether you say, now let us sum up, that whether you say we add this particular number to one number to get the next number of the sequence, or the difference between the two members of the sequence will be the same. Like 27 minus 20 will be 7. 34 minus 27 will be 7. I hope you all are understanding what is arithmetic progression or arithmetic sequence. Okay. So let us start. First we have seen that what is arithmetic progression. Now if I write, or if I take a very common arithmetic progression or AP, the abbreviation of arithmetic progression is AP. Generally we call it AP. Okay. So let us take a sequence or progression 2, 4, 6, 8, 10. This is a very simple. Every time we are adding 2 to each number to get the next one. Or what is the difference between the two? 4 minus 2 is 2. 6 and 4, the difference is 2. Okay, next thing, if I ask you, can you count how many terms are there? 1, 2, 3, 4, 5. That means whenever in a sequence or progression we can count the number, that means it is finite sequence. We know the numbers. So this sequence will be known as finite sequence. And if I write just like this, up to infinity or dot dot dot, we don't know where this progression is going to end. That means we don't know the last term, and then we call such sequence as infinite sequence. Like if I write 3, 5, 7, 9. So this is a finite sequence. We know that there are only 4 terms. But this is an infinite sequence because we don't know how many terms are going to be there in the sequence. So that's how we categorize sequence as finite sequence and infinite sequence. Okay. Now let's further see that we are having this sequence, that is 2, 4. I am taking a very common sequence, 6, 8, 10. Okay. If I ask you how many numbers are there, so you will say 5 members or 5 numbers are there. The very first term is 2. Okay, and the terms we denote in any progression or sequence, the term we denote is by the capital letter T. So likewise, if I ask you how to denote the first term, that would be T1. Here we can denote it by T1. Also generally we denote it by the letter small a. Both are same, whether you write T1 or you write small a, it will represent the first member of that sequence. Generally you will find that it is denoted by a small letter a. Okay. Now what is the second member? We will denote it by T2, and likewise we denote T3, T4 and T5. If I write T17, that means which term I am talking about? The 17th term I am talking about. If I write T108, which term of the sequence I am talking about? That is 108th term I am talking about. Okay, so this is how we denote the terms. Now let us come to the next thing. So that's how we know that T1, T2, T3 will represent the terms. Now as we have seen, what is the difference of these two numbers? That is 2. That is 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is again 2, that 10 minus 8 is again 2. Every time the difference of the two numbers, it is coming 2. It can come 3, it can come 7, whatever, depending upon the sequence we are taking. So every time the difference of the two number is coming same, that means the difference is constant, or you can say that the difference is common, and that's how we call this as a common difference. Okay, it is known as common difference and denoted by the letter small d. So I think now you are aware with the notation. If I write a, small a, that is the first term, or I can write T1. If I am writing T3, that means I am talking about the third term. What is small d? That is the common difference. Now how many numbers, or how many numbers are there, or how many terms are there in the sequence? 5. So number of terms, n will tell you the number of terms. So there are 5 terms, 1, 2, 3, 4, 5. So n will tell you the number of terms. Okay, I think these are the things. Let us take another sequence. We can take 3, 6, 9, 12, 15. How many terms again? It is 5 terms are there. Now if I ask you what is the first term, that is A, which is 3. What is the common difference? How to calculate the common difference? See, 6 minus 3, that is 3. So every time, whether you say that 3 plus 3 6, 6 plus 3 9, 9 plus 3 12, 12 plus 3 15, you can see it like that, or else 6 minus 3 3, 9 minus 6 3, 12 minus 9 is 3. How are we finding the, I want you all to see the pattern, how are we finding the common difference? That we are actually subtracting a term from its preceding term, that is 9 minus 6, second term minus first term, third term minus second term, fourth term minus third term, or fifth term minus the fourth term. Are you getting this thing? Whenever we want to calculate the common difference, it is going to be same. So we can calculate it anyhow. You can subtract T2 minus T1, you will get 6 minus T2 is what? 6. T1 is what? 3. So you will get the common difference. You can get it like this. T3 minus T2, that is T3 is what? 9. T2 is what? 6. You will get the same thing. You can also calculate as T4 minus T3. 12 minus 9. You will get the same answer. Every time the result is going to be the same, or it is going to be constant or common. That's why it is called common difference. Okay. So this is how we have seen. Now if I ask you, again I'm going to write the very common sequence or progression, 2, 4, 6, 8, 10. If there are 5 terms in the sequence, and so far it is a finite sequence. If I ask you what is the 6th term of the sequence, so you can answer that since the common difference is 2, so of course the 6th term is going to be 12. 1, 2, 3, 4, 5, 6, it is going to be 12. What will be the 7th term? It is going to be 14. But what if I ask you which term or the number of term I ask you to calculate the 108th term? That means if I ask you what is the 6th term, so that 6th term will be your 12. You can easily calculate, or you can easily tell me. But what if I ask you to calculate the 108th term? What if I ask you to calculate the 50th term of this sequence? So it is not possible for us to calculate or to add every time and to go up to 50th term or up to 108th term. And that's why we are going to make a formula, or we are going to write a formula, so that every time we can use that formula to calculate the term. Okay, and let's see here. Now this is your first term, so we can write A here. This is your first term, whether you write denoted by small a or you can denote it by T1. Okay. Now you tell me, if I want to write the next term, what to do? That we have to add the common difference. First term is A. If I want to write the second term, I have to add the common difference. So it should be the first term plus the common difference. Is it correct? Have I written it correct? Because whenever I want to write a term, first term, if the common difference is 3, I have to add 3 in the first term. So 3 plus 3, 6. How to get the next term? Again we have to add 3, that is 9. So first term we have added common difference and we have come to second term. Now how to get the third term? That in the second term, which is A plus D, we again have to add the common difference, that is A plus D plus D. Eventually it will become A plus D will become 2D. That means first term, second term and the third term. How to write the next term? That is A plus 2D. If I write it like that, the third term is now coming A plus 2D. If I write it like this, A plus 2D. Okay, so this is first term, second term, third term. How to write the fourth term? Again we have to add the common difference. That means A plus 2D, third term, and then we have to add the common difference. What it will be? A plus 2D plus D, it will be 3D, isn't it? So if I write it properly, it will be a plus 3d, isn't it? So this is how we are writing our terms. So far I have written 4 terms. If you see the pattern, first term is a, second term is a plus d or a plus 1d. This is your first term, this is your second term, this is your third term, and this is your fourth term. How are we getting the third term? It is a plus 2d. How are we getting the fourth term? It is a plus 3d. So I hope that you are now seeing the pattern. Like if I want to write a term, third term, we always take the coefficient of d one less in number. Like if I'm talking about the third term, the coefficient of d will be 2. If I'm talking about the fourth term, the coefficient of d will be 1 less, that is 3. So that's how. If I'm talking about the seventh term, wouldn't it be a plus 6d? Because the coefficient of d should be 1 less in number, that is a plus 6d. Is it clear? If I ask you to write the 11th term, it would be a, as every term contains a, plus what is this? 10d, because whatever number we are calculating, the coefficient of d should be 1 less in number, so it should be 10d. Is it clear? And that's how we are going to generalize the formula. What if we want to calculate the nth term? Nth term, it could be anything. N could be 108, n could be 51, it could be 53. Whichever term we want to calculate, that value of n we will take. So it is, every term will contain a plus what is the coefficient of d? 1 less in number. Which term we are calculating? Nth term. 1 less in number would be n minus 1, isn't it? And then multiplied by d. And that's how we have a general formula to calculate the term. Is it clear? This is the general formula to calculate a term in AP. If I ask you to calculate the 17th term of the AP, so what is the value of n? It will be 17. Then a, that would be the first term of the sequence, plus n minus 1. What is your n? 17. Minus 1 will be 16 into d. You can always calculate the common difference from the sequence. So this is the general formula. I hope you are going to remember this, and I am going to write this formula here so that you can see the general term. This is called the general term, equals a, which is your first term, plus n minus 1 into d. d is your common difference. Is it clear? Okay. Now let's take some question. Exercise 10a. Show that the progression, which progression they have given, 13, 15, 17, 19 and so on, is in AP. They are giving that this sequence is actually arithmetic progression. Write down its first term. You have to calculate the first term, common difference, and the 20th term of the sequence. First thing, is it a finite sequence? No, because we don't know what is the last term. So first, it is in infinite sequence. We don't know where it is ending. Is it a finite sequence? No, it is not a finite sequence. We don't know where it is ending. Second thing, first we have to calculate the first term. First term we denote by small a. Second, we have to calculate the common difference. Common difference is small d. And third, we have to calculate the 20th term, Tn. 20th term, that means T20. When I write 20, that means which term we are talking about? 20th term. So what is the first term? It is very much clear that the first term will be 11. What is the common difference? How to calculate the common difference? That is second term minus first term, or third term minus second term, or fourth term minus third term, or fifth term. Any time, just fourth minus third, sixth minus fifth, 18th minus 17. Okay, just you need to subtract these terms. Okay. So if you want to calculate the common difference, 13 minus 11 is 2. On every time you can see that common difference is going to be same. And here we are going to calculate the 20th term. What is the formula? That is a plus n minus 1 into d. A plus n minus 1 into d. Okay. Now a plus n minus 1 into d. What is our a? That is 11 plus n minus 1. What is which term we are going to calculate? 20. So 20 minus 1, that is 19 into d. What is the value of d? That is 2. Is it clear? So 11, that will be 38, and simply it is 49. So the 20th term of this series or sequence will be 49. Likewise, you can calculate the 40th term of the series. Is it clear? That's how we simplify the questions. Let's see some more questions. Let us take one more question. It is 11, then 5, minus 1, minus 7, minus 13, and so on. And this is given that this is in an AP, or this is an AP given. They are asking you to calculate the first term. They are asking you to calculate the first term, common difference, and the 12th term. Okay. First, they are asking you to calculate the first term denoted by A. Second, they are asking you to calculate the common difference. Third, they are asking you to calculate the 12th term, that is T12. Is it clear? Simple. What is the first term? That is 11. So the answer will be 11. What is the common difference? How to calculate the common difference? Second minus first, or third minus second, and or fourth minus third. Every time to get the common difference, we have to subtract the preceding term from a term. 5 minus 11. So what is common difference? If you tell me whether I am writing it correct or not, we can calculate common difference as T2 minus T1. We can also calculate common difference by subtracting T3 minus by doing T3 minus T2. We can also calculate T4 minus T3. Anyhow we can do it. Okay. So I am going to take this T2 minus T1. Whatever number you will take, it will come same. T2 is 5 minus T1 is 11. Okay. And when you subtract, this will give you minus 6. That means, by the way, common difference could be minus 6 as well. It could be in fraction. So there is no need to worry. It could be plus, minus, in fraction, whatever. So common difference is coming minus 6. So here the value of D is coming minus 6. Is it clear? And then we have to calculate the 12th term, that is T12. What is the formula? A plus n minus 1 into D. So A plus n minus 1. What is your n? 12 minus 1. 12 minus 1, that is 11 into D. Now what is your A? It is 11 plus 11 into D. If you see, we have calculated our D as minus 6. Is it clear? 11 into minus 6. 11 plus, or we can multiply it here, plus minus minus. 11 into 6, that is 66. Now this will give you minus 55. So your 12th term will be minus 55. Likewise, you can calculate the 100th term of this sequence. That would, you can calculate that T100 would be A plus n minus 1 into D. So this is how we are solving the question. Let us take another question. Okay, so one more question. If I write 6, then we have a mixed fraction 5 whole 1 upon 2, and I have 5, then 4 whole 1 upon 2, 4. This is all given in AP. And then they are asking you to calculate again the same first term, common difference, and the 9th term of this sequence. What is the first term of the sequence? Or before we write the first term, is it okay that if we convert this mixed fraction into the improper fraction? That would be 6, and that is 11 by 2, 5, that would be 9 by 2, and then 4, and then so on. Okay. Now, what is the first term? That would be 6. What is the common difference? How to calculate the common difference? T2 minus T1, or T3 minus T2, or T4 minus T2, whatever you feel like doing. Okay. So I am calculating it as T2 minus T1. T2 is 11 by 2 minus T1 is 6. You need to take the LCM. I hope you all can simplify. That will give you 11 minus 12 upon 2. So it is simply coming minus 1 upon 2. The value of D is coming minus 1 upon 2. To common difference, if I write, it is minus 1 upon 2. Is it clear? Now the third part of the question, they are asking you to calculate the ninth term, that is T9. So again we have to apply the formula, that is A plus N minus 1 into D. What is your A? That is 6, first term, plus N minus 1. What is your N? Ninth term. 9 minus 1 would be your 8 into D. What is the value of D coming? Be very careful, it is coming negative. So it would be minus 1 upon 2. Let's simplify. 6 plus minus minus, we can cancel it, it will be 4. Now it is coming 4. So it is simply 2. So the ninth term is coming 2. Is it clear? Now I want you all to see one thing, is that if I tell you that for a sequence, let's say the sequence, the first term of a sequence is 4, okay? And I tell you the common difference is 3. So can you write the sequence? Yes, every time we have to add the common difference. So first is 4, next would be 4 plus 3, 7, next will be 10, next will be 13. That means whatever is the common difference, we have to add the common difference to each term to get the next term. Here if I ask you what is the first term? 6. What is the common difference? Minus 1 upon 2. And every time you have to add the common difference to get the next term. 6 plus of minus 1 upon 2. That will be your next term. I hope you are getting it. Otherwise, when we move ahead, you will understand. So this is the next question. This is this question actually. Now let's see another question if we can solve. Okay. Here I have find the nth term. One more question is find the nth term of the AP. AP is 13, 7, 1, minus 5, minus 11. You have to, this is your AP and it is a infinite series. So they are asking you to calculate the ninth term. First part they are asking you to calculate the ninth term. Also they are asking you to calculate the 16th term, and they are asking you to write the nth term. That means that nth means any term, general value. So they are asking you to calculate or to write the nth term, Tn. So we know the formula, A plus n minus 1 into D. A plus n minus 1 into D. We will not write anything for now because they are asking us to write the nth term. So we will write this Tn as it is. What is our A in the series? That is 13 plus n, we will write it as like this. And D, what is a common difference? This minus this, 7 minus 13. What will be the common difference? Minus 6, if you remember. It is T2 minus T1. 7 minus 13. It would be minus 6. Or T3 minus T2. That is 1 minus 7. It would be minus 6. So every time when you calculate, it will come minus 6. So here D is coming minus 6. So just simplify it. That is 13 plus minus minus 6. I am writing it like that, and minus 1. Is it okay? Now let us open the bracket. Minus 6n minus minus plus 6. 13 plus 6 would be 19 minus 6n. So the general term is coming, Tn is coming 19 minus 6n. Are you getting this thing, that the general term is coming, or nth term is coming 19 minus 6n. Now they are asking us to calculate the, if I write this 19 minus 6n here, Tn is coming 19 minus 6n. Okay. Now let's see the next part of the question. They are asking you to calculate the ninth term. You can go in a regular way that to calculate the ninth term, the formula would be A plus n minus 1. What is our n? That is 9. 9 minus 1 would be 8 into D. So that's how you can put the value of your first term. You can put the value of D. Otherwise, we are knowing the general term. So if we want to calculate the ninth term, can we write or can we put the value of n as 9, because this is the nth term, it could be any term. So which one term we want? Ninth term. So if we put the value of n as 9, so it would be T9 is equals to 19 minus 6. What is our n? That is 9. Are you getting this? So that would be T9, 19 minus, that would be 54. Will be 35, I guess. Yes, it will be 35 and with minus sign. So your ninth term would be minus 35, ninth term. Okay. Likewise, we can calculate the 16th term. You can calculate the 16th term by the very method we have learned, that T16a plus n minus 1 into d. Otherwise, from here, since we know the general term, just put the values of n. What is the value of n here? 16. So it would be T16, 19 minus 6 into 16. So here it will be 16, 19 minus that is 36, I guess 96 it is, and then when you subtract, that will give you minus 77. So your 16th term would be minus 77. That's how we have calculated the ninth term, the 16th term and the general term. Okay. Now let us take another question. Here I am going to take a different question. It is AP. One AP is given 6, 10, 14, 18 and so on, and it is ending at 174. Question is, how many terms are there in this AP? So first thing, this is an AP and they are asking how many terms are there. That means if I write 2, 4, 6, 8, how many terms are here? 4 terms are here. So that is the question. They are asking that how many terms are going to be here in this finite arithmetic progression. To see how many numbers are there, if you see here, this is your first term, second term, third term, fourth term, then fifth, sixth, seventh. If somehow we'll get to know that at which place this number is coming, so we'll get to know that how many terms are there, since it is the last term of the series. Let's suppose, I'm just considering that this term is coming at 23rd place. That means then how many numbers are going to be there? How many terms are going to be there? 23 terms are going to be there in the sequence. So that is our idea. The last term we are going to find out for this term, at which place this term is coming. So that means at which place or what is the number of this term. That means we are supposed to calculate small n for this term. So what is the formula? The general formula is Tn a plus n minus 1 into d. Which term we are talking about? This term. So what is the value of the term? It is 174. So it is simply 174. The value of the term is 174. A is the first term, that is 6 plus n minus 1. N. We want to calculate what is n, which place or which term it is. So it is n as it is minus 1, and d. How to calculate d? Second minus first or third minus 2 and so on. So 10 minus 6, 4. So the value of common difference is 4. Let us open the bracket. You can solve anyhow. This will be 4n minus 4. 174, 6 minus 4 would be 2 plus 4n. Is it clear? Now this 2 will come to this side, 174 minus 2, and there we have 4n. So this will be 172 equals 4n. Of course, n 4 being in multiplication, it will come here and it will come here in division. So n would be equals to 172 by 4, and that's how the value of n is coming 43. If you simplify, the n will be 43. That means which term is this? 43rd. That means total number of terms. How many terms are there? Total in number there are 43 terms, because the last term is coming at which place? 43. So that's how we calculate the term.